Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2005. So let's get started. First problem, a scout troop buys 1,000 candy bars at a price of $5 for $2. They sell all the candy bars at a price of $2 for $1. What was the profit in dollars? Okay, so 5 for $2 means that 10 for $4, so 1,000 for $400. And then they sell it at a price of 2 for $1, so 10 for $5, so 1,000 for $500. So they used $400 and they earned $500. So this is 500 minus 400 equals 100, so the profit was 100. The answer is A. Number 2, a positive number x has the property that x% of x is 4, so it's x times x over 100 equals 4. X squared equals 400, so x equals 20, so x is 20. The answer is D. Number 3, a gallon of paint is used to paint a room. 1/3 of the paint is used on the first day. On the second day, 1/3 of the remaining paint is used. What fraction of the original amount of paint is available to use on the third day? So we have 1/3 of the paint is used, so we have 2/3 left, and then out of that, we have 1/3 used. So this times 2 out of 3 is the one left. The answer is 4/9, so the answer is D. Number 4, for real numbers a and b, define a diamond b equals root a squared plus b squared. What is the value of 5 diamond 12 diamond 12 diamond minus diamond minus diamond minus 12 diamond minus 5? So this will be root 5 squared plus 12 squared. That's 13. So this is 13 diamond and then 13, right? Since this squared plus this squared is the same thing as 12 squared plus 5 squared. So it will be 13 times 13. This is root 13 squared times 2. This is 13 root 2. The answer is D. Problem number 5. Brianna is using part of the money she earned on her weekend job to buy several equally priced CDs. She used 1/5 of her money to buy 1/3 of the CDs. What fraction of her money will she have left after she buys all the CDs? Okay, she several equally priced CDs, so 1/5 of money would get 1/3 CDs. So if we multiply 3/5 of her money get her 3/3 of her CDs. So she will use 3/5 of her money, so she will have left 1 minus 3/5. The answer is 2/5. So it's C. Number 6, at the beginning of the school year, Lisa's goal was to earn an A on at least 80% of her 50 quizzes for the year. She earned an A on 22 of the first 30 quizzes. If she is to achieve her goal, at most how many of the remaining quizzes can she earn a grade lower than an A? Okay, so this means that she doesn't have to earn an A on 20% of 50, right? And 20% of 50 is 10, but then here we have used 8 out of 30, so 8 are below an A, right? And so the total is 10, but 8 are already used, so we have 10 minus 8 equals 2 left. So on at most 2 of the remaining quizzes can she earn a grade lower than an A, so the answer is 2. It's B. Number 7, a circle is inscribed in a square. Then a square is inscribed in the circle, and finally a circle is inscribed in the square. What is the ratio of the area of the smaller circle to the area of the larger circle? Okay, so we have this circle, and so what is the ratio of the area of the smaller circle to the area of the larger circle? Okay, so what we have to notice is that this square can be rotated, right? So it can be this, right? So if this is R, then this will be 2R, right? This will be 2R, this will be 2R. And so this would be 2R, and so this is also 2R, and so this would be root 2R, and so this is R, right? So smaller circle, this is pi r squared, and large circle, this is root 2 r squared, right? So it's 2 pi r squared. And so the smaller circle to the area of the larger circle, no, it's the larger square, right? So this is this is 2 root 2r. So largest is squared, so that is 8r squared. So the answer is this over this. It's this, so it's pi over 8 since these two cancel. So pi over 8, the answer is B. Number 8, an 8 foot by 10 foot floor is tiled with square tiles of size 1 foot by 1 foot. Each tile has a pattern consisting of 4 white quarter circles of radius ½ foot centered at each corner of the tile. The remaining portion of the tile is shaded. How many square feet of the floor are shaded? Okay, so this is so the floor is 8 foot by 10 foot, so it's 80 square feet. And then this is 1 square foot. And then this is radius ½ foot, so this area right here, that would be that would be 1 squared minus this is 1/2, so half squared pi. The answer is 4 minus pi over 4 over 4. So the but then we have 80 of these, right? Since the whole thing is 80 square feet, and so 4 minus pi over 4 times 80. This is 80 minus 20 pi. The answer is 8. Problem number 9. On one fair die has faces 1, 1, 2, 2, 3, 3, and another has faces 4, 4, 5, 5, 6, 6. The dice are rolled and the numbers on the top faces are added. What is the probability that the sum will be odd? So to get this, we have only a few ways. One, we have so the first die could be 1, 2, 3. The second could be 4, 5, 6. And so for the sum to be odd, we need 1, 4, 1, 6, 2, 5, 3, 4, and 3, 6. Right? And so this will be 14, 16, 25, 34, 36. So there are a total of 3 squared 9 ways. So out of 9, there are 5. So this is 5 out of 9. The answer is D. Number 10, in ABC we have AC equals BC equals 7 and AB equals 2. Suppose that D is a point on line AB such that B lies between A and D and CD equals 8. What is BD? Okay, so we have triangle ABC. We have triangle A, B, C. And then AC equals BC equals 7, so these two are 7, and AB is 2. Suppose that D is a point on line AB such that B lies between A and D and CD equals 8. Okay, so what this is saying is B is moving up a little bit like that, and then so this would be another straight line like that, and then while this would still be 7, there would be another line, and then this will be 8, right? This is D, and so what we need is and so what we need to do right here is split this like that, and so this will be and so since the whole thing is 2, this will be 1 and 1, right? And since this is a right triangle, so this would be root 48, and since this is also a right triangle, we can use Pythagoras for 148, 8, and let's say that this is x, right? And so 8 squared equals 1 plus x squared plus 48. 64 minus 48 equals 1 plus x squared. So this is 16. 16 equals 1 plus x squared. X equals 3 and x equals minus 5. So what is BD? So x can't be minus 5, right? So it's 3. The answer is A. Number 11. The first term of a sequence is 2005. Each succeeding term is the sum of the cubes of the figures of cubes of digits of the previous term. What is the 2005th term of the sequence, right? So we have 2005, and then 2 cubed plus 5 cubed, this is 125 plus 8, so this is 133. And then 1 cube plus 3 cube plus 3 cube, this is 27 plus 2. So this is, this is 27 plus 27, so this is 55, right? So that will be 55. And then 5 cubed plus 5 cubed, this equals 125 plus 125, this is 250. And so the results of this will be the same as the results for this, right? Because we have only 2 and 5, and same here. And so these three, so 250, 133, 55. These three will keep going on, and the 2005th term is, let's divide by 3, 2005. This is 3 times 6, and then 6, and then it's 3 times 8 is 24, and then plus 1, right? And so the 2005th term would be 1, right? And so yeah, so we have 1 that is a remainder, so this will be the 2004th term, and then the 2005th term is the next term. The answer is 250, so it's 250, it's E. Problem number 12. 12 fair dice are rolled. What is the probability that the product of the numbers on the top faces is prime? Okay, so so if 12 dice are rolled, then the total probability is 12 to the 12th power. No, it's 6 to the 12th power. And then the probability that the product of the numbers on the top faces is prime, that would be 1, 1, 1, 1, 1, all the way to 1, 1, and then we have a 2, or we have a 3, or we have a 5, right? And so we can't do a 7 because that won't be because that won't be one of the numbers on the fair dice. And so here we have 12 choices for where to put the 2, and then 12 choices for where to put the 3, 12 choices for where to put the 5. So this is 36. The answer is 72. Yeah. This is 6 squared over 6 12th power. This is 6 to the 10th power over 1. So the answer is E. Problem number 13. How many numbers between 1 and 2005 are integer multiples of 3 or 4 but not 12? Okay, so 3 or 4 but not 12, so this means that we need to divide 2005 by 3, and then take out the amount that we've divided by 12, and then add divided by 4, and then subtract the amount that we've divided by 12. And so 2005 divided by 3, that's like 668, right? So that's 668 point something something, and then divided by 12, that will be minus 167 plus, and then minus 4, that would be 5. That would be 501, and then minus this is the same thing, minus 167. So if you add these two together, then that will be 1169 minus 167 times 2, that is 334. The answer is 835, so the answer is C. Number 14, equilateral triangle ABC has side length 2, M is the midpoint of AC, and C is the midpoint of BD. What is the area of CDM? Okay, so ABC has side length 2, and this is the midpoint, so this is 1 and this is 1. AC is the midpoint of BD, but this is 2, so this is also 2. What is the area of CDM? Okay, so this is 60 degrees since it's equilateral, and so this must be 120 degrees. And so if we make a line down here, then that must mean that this triangle is a 30-69 triangle. And so since this is 60 degrees and this is 1, then that must mean that this is root 3 over 2. And so the base is 2, so it's 2 times the height, root 3 over 2, and then multiplied by 1/2, so this is root 3 over 2. The answer is C. Number 15, an envelope contains 8 bills, 2 1s, 2 5s, 2 10s, and 2 20s. 2 bills are drawn at random without replacement. What is the probability that their sum is $20 or more? Okay, so our total number of things that we could get is 8 choose 2, right? Since we choose 2 bills from these 8. And then the probability that the sum is $20 or more. So this can either be 2 10s or at least 1 20. Right, so if we have 2 10s, that's only one possibility. So we have one possibility plus having 2 20s, but then we have to differentiate these 20s, right? So having 120, having one $20 bill, this would equal 2 times, because we could choose either of the 20s. And then we have to choose one from these 6, right? So it's 6 choose 1, so this is just 6, this is 12, so 1 plus 12, and then 2, and then 2 $20 bills, this will just be 1, right? So plus 1, this is 14, that's 14 over 8 choose 2 is 28, so this is 1 over 2. The answer is D. Number 16, the quadratic equation x squared plus mx plus n equals 0 has roots that are twice those of x squared plus px plus m equals 0, and none of m, n, and p is 0. What is the value of n over p? Okay, so let's say that the roots of this is so let's say that the roots of this is a and b. Then these roots are twice those, right? So this is 2a and this is 2b, and so a plus b equals minus p, and ab is m according to this one. But then here 2a plus 2b equals minus m, and 4ab equals n. So yeah, so getting these two together like that, then that would say that minus 2p, this is 2a plus 2b, right? So that is minus m, 2p equals m. And then these two together, that would say 4m, because 4ab equals 4m, 4m equals n. And so what is the value of n over p? N over p, this equals m. N is 4m, right? And p is 1/2 m. And so these two cancel, this is 8, so the answer is D. Number 17, suppose that 4 to the 8th power is 5, 5 to the bth power is 6, 6 to the cth power is 7, and 7 to the dth power is 8. What is 8 times b times c times d? Okay, so if you know the concept of log, then this should be easy for you, because this just says that log, yeah, because that says that a is log 5, b is log 5 over 5 of 6, c is log 6 of 7, and d is log 7 and 8, right? But then this is 8 is 2 to the 3rd power, right? So this is 2 to the 3rd power, this is 7, this is 3 log 7 2. And same for here, 4 is 2 to the 2nd power, right? So this is 1/2 log 2 5. And so if we multiply this and this together, then these all cancel, right? These all cancel, because we have 2 2, and we have 5 5, we have 6 6, and we have 7 7. And so what's left is this 3 and this 1 over 2. So this is 1/2 times 3, this is 3 over 2. So the answer is B. All of David's telephone numbers have the form 555 A, B, C, D, E, F, G, where A, B, C, D, E, F, and G are distinct in digits and in increasing order, and none is either 0 or 1. How many different telephone numbers can David have? Okay, so taking out 0 or 1, the leftover numbers that we can have is 2, 3, 4, 5, 6, 7, 8, 9, right? But then, so this is 8 numbers, but then these have to be in increasing order, and these are 7 numbers, right? And so what we have to do here is take out one number, and then the others would be A, B, C, D, E, F, G in that order, right? Because they have to be in increasing order. And so we could take out 2 or 3 or 4, 5, 6, 7, 8, or 9. So there are eight choices to take out from. So we have 8 possible numbers. So the answer is 8. It's D. Problem number 19. On a certain math exam, 10% of the students got 70 points, 25% got 80 points, 20% got 85 points, 15% got 90 points, and the rest got 95 points. So 10% got subtracting 10%, 25%, 20, 15% from 100%, then what's left is 25%, 35, 25, 50%, so 30% got 95 points. This is 30%. And so if we think that there are 100 students total, then the mean would be 10 times 70, 700, plus 25 times 80, so that's 100 times 20, 2000, plus 20%, so 20 times 85, so that is that is 20%, 20 times 85, that's 170, that's 1700, so 1700 plus 15 times 90, so this is 945, 135, 1350, plus 95 times 30%, 95 times 3 is 15, this is 2728, 2850, right? And so if we add all those together, this is 3,000, 4,400, that's this much, plus 1350, 2850, so that's 1400 plus 2800, that is 4400, so this is 5800 plus 2800, so that is so that is 8600, so that's 8600, and if we divide by 100, then that would be 86. So this is the mean, right? And then the median is the number, is the score, actually, score at 50%, right? And so first 10% is 70 points, and then 25%, that's 35%, and 20%, that's up to 55%, right? So the median is 85 points. This is 85 points. So the mean is 86, the median is 85, so the difference is 1. The answer is B. Number 20, what is the average mean of all 5-digit numbers that can be formed by using the digits 1, 3, 5, 7, and 8 exactly once? Okay, so we could use 5-digit numbers that can be formed by using the digits 1, 3, 5, 7, and 8. Oh, right. So there are so we have 5 digits, right? And then we will use 1, 3, 5, 7, and 8. So let's say that there's 1 here. Then we have the leftover 4 digits, right? And then one would be here as long as the 3, 5, 7, 8 could make different combinations, right? And so the combination, different combinations of 4 numbers, so that could be 4 times 3 times 2 times 1, so that is 6 times 4, that's 24. So the number that's possible is 24, and so this would be for the 1, 10, 100. Yeah. So for the 10,000s place, it will be 1 plus 3 plus 5 plus 7 plus 8 multiplied by 24, right? Times 24. And then, not 25, 24. And then, since this itself is 24, this is 24 times 24. And then, since this is in the 10,000 place, this will be 1, 0, 0, 0, 0, right? And then in this place, this would be 24 times 24 times 1,000, and then this would be 24 times 24 times 100, and so the whole sum would be 24 times 24 times 11111, right? And so there are so let's just keep it like this. So this is the total sum, and then it says we have to get the average. So the number of 5-digit numbers, that is 5 factorial. This is 5 times 24, and so this is 24, 24, 11111, all over 5 times 24. So these two cancel, so this is 24 times 11111, that's 26664. No, so that's 26664 over 5, and so that is 4. No, that is all over 10, and then this would be 8, 1, 2, 1, 2. Yeah, so that's 10. This is 4, 5, 2, 3, 2, 3, 2, 3, and then that will be 2. That will be 8. And so this is 53332.8, and then we could get rid of these over 10, right? And so what we need to find is this. This is the answer, so the answer is C. Problem number 21. 40 slips are placed into a hat, each bearing a number 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, with each number entered on 4 slips. 4 slips are drawn from the hat at random and without replacement. Let P be the probability that all 4 slips bear the same number. Let Q be the probability that 2 of the slips bear a number A and the other 2 bear a number B is not equal to A. What is the value of Q over P? Okay, so each number is entered on 4 slips, and then 4 are drawn from the hat at random and without replacement. So let P be the probability that all 4 slips bear the same number. Okay, so the total number of possible outcomes, this is 40 choose, yes, this is 40 choose 4, right? But then for P there will be only 10 ways. 10 ways that 10 ways that it could happen. And then Q, 2 of the slips bear a number A and the other 2 bear a number B is not equal to A. Okay, so B and then so Q would be that there is 10 to so 2 of the slips bear a number A and the other 2 bear a number B is not equal to A, and so that means that from the 4 slips that we draw, we have to choose 2 of the slips to bear 1 of the number A, right? No, actually, so first we have to get the 2 numbers B and A, and so to get those numbers we have to get 2 of the 10, right? So that's first 10 choose 2, 10 choose 2, and then multiply that by which 2 of the, so let's say that we chose 5 and 9, and so which 2 of the 4 5s would be chosen here? So that would be 4 choose 2, and then which 2 of the 4 9s will be chosen? That would also be 4 choose 2, and so this would be 10 choose 2 is 10 times 9 over 2. This is 45 times 4 choose 2 is 6 times 4 choose 2 is 6. And so the Q over P is 45 times 6 times 6 over 40 choose 4, all over 10 over 40 choose 4, right? And so these two cancel, and this is 45 times 6 times 6 over 10, and then this becomes 9 and 3, and so this is 9 times 3 times 6. This is 81 times 2. This is 162. So the answer is this is 162. So the answer is A. Problem number 22. For how many positive integers n less than or equal to 24 is n factorial evenly divisible by 1 to 2 to all the way to n? Okay, so we know that this equals n plus 1 over 2, and so n factorial is evenly divisible by this. And then if we divide the n, then that means that n minus 1 factorial is divisible by n plus 1 over 2, right? And so yeah. So the way that this is not evenly divisible is n plus 1 is a prime. That's not a 2. That's not a 2. Right, because if n plus 1 is 2, then this whole thing would just be 1, and then that would be divisible by 1. So n has to be less than or equal to 24 to n plus 1 has to be less than or equal to 25, right? And so if n plus 1 is prime and it's not 2, then n plus 1 can be 3, 5, 7, 11, 13, 17, 19, and 23, right? And so there are 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 8 ends that are not divisible, right? And so so we have 24 total ends, 24 total ends, and then minus 8 that are not divisible, so that 8 are not. So this is 24 minus 8. This equals 16, so the answer is C. Problem number 23. In trapezoid ABCD, we have AB parallel to DCE is the midpoint of BC, and F is the midpoint of DA. The area of ABEF is twice the area of FECD. What is AB over DC? Okay, so we have this trapezoid ABCD. We have AB parallel to DC. No, this has to be C. This has to be D. And so this is parallel. And so these two are parallel. E is the midpoint of BC. F is the midpoint of DA. The area of ABEF, so we have to connect these two. The area of ABEF is twice the area of FECD. What is AB over DC? So this area is twice that of this, right? So if we say that this is A and this length is B, then FE, this would be A plus B over 2, right? Since this length is the middle length of AB and DC. And so, yeah, and these two heights would obviously be the same, so let's just say that this is H, this is H. And so the area of ABEF would be B plus A plus B over 2. Yeah, so it's this equals B plus A plus B over 2. This times H times 1 over 2. And then FECD, this would equal A plus B over 2. A plus B over 2. This times H times 1/2. But then ABEF is 2 times FECD, right? And so this equals 2 times FECD. This is this times 2. And if we cancel these two out, then this becomes 3B plus A equals equals 3. Yeah, so 3B plus A over 2. That equals 3A plus B. And so 3B plus A equals 6A plus 2B. And so 5A equals B, right? And so what is AB over DC? 5A is B, and so that means that A is 1, B is 5, and And so AB over DC, that is B over A. B is 5A, right? So this is 5A over A. This is 5. So the answer is 5. It's C. Problem number 24. Let x and y be two-digit integers such that y is obtained by reversing the digits of x. So if x is 10a plus b, then y would be 10b plus a. The integers x and y satisfy x squared minus y squared equals m squared for some positive integer m. Okay, so let's plug these values into that equation. 10a plus b squared minus 10b plus a squared equals m squared, right? So it's 100a squared plus 2b squared, no, plus b squared minus 100b squared plus minus a squared. So this equals m squared, right? And so what is x plus y plus m? X plus y, this is 11a plus b plus m. That's what we want, right? And then if we order that, then this equals 99a squared plus 99a squared minus 99b squared. This is 99 times a squared minus b squared equals m squared. So m equals root 99a squared minus b squared. And so m equals 99 root a squared minus b squared. What is x plus y plus m? Right? So 11 times a plus b plus 3 root 11 a squared minus b squared. This is so this is what we want to get, but then so let's go back to here, and if we split these up, then this equals 9 times 11 times a plus b, a minus b. If this is m squared, and m is a positive integer, then that means that a plus b is 11 and a minus b is 1, right? And so if a plus b is 11 and a minus b is 1, then this means that a equals 6 and b equals 5. And so if we put these values into this, then we can see that it's 11 times 11 plus 3 times 11, and these two multiplied are 11, right? So this is 11 times 11. This is 121 plus 33. This is 154. So the answer is E. Last problem, problem number 25. A subset B of the set of integers from 1 to 100 inclusive has the property that no two elements of B sum to 125. What is the maximum possible number of elements in B? Okay, so we have subset B from 1 to 100 inclusive, right? So yeah, no two elements of B sum to 125, and so the B so 125 equals 62 times 63, right? And so it could be all positive integers, all positive. So taking this into account, it will be all positive integers from 1 to 62, right? Because beyond 62, it will sum to 125, right? So it's all the integers from 1 to 62. This is 62 possible possible elements, and the 62 is the maximum, right? So the answer is C. It's 62. And that was problem number 25, and thank you for watching.